All tankers that carry flammable cargo need inert gas systems to ensure safety. Vapors that come from the cargo, be it crude oil, gasoline, or something else, are flammable and can lead to explosions under the wrong circumstances. As you can understand, preventing such situations from arising is a must in order to avoid environmental damage, injuries, or even loss of life. Inert gas systems prevent the development of these dangerous circumstances by producing inert gas that is injected into the cargo space. The primary components of an inert gas system are the inert gas generator, the deck water seal, and the PV breaker. In this animation, we'll explain a little about the production of inert gas. The most common method of producing inert gas is by means of a generator. The main components are the fuel pumps, the fans, and the generator. The fuel pumps are responsible for bringing the diesel needed to the generator at the correct pressure. These pumps must be delivered in pairs to ensure the availability of fuel at all times. Fuel pump redundancy is one of the requirements of the safety regulations. The fuel pumps are frequency-driven to allow the generator to run at any desired capacity or oxygen percentage. The air fans are to ensure a continuous flow of air to the generator. Even the air fans are redundant, as required by the safety regulations. The fans draw in air from the engine room and blow it towards the generator. To ensure optimal combustion, the inert gas generator continuously secures the right fuel-to-air ratio, whatever the required capacity. The ultimizing burner technology creates extremely small fuel droplets and mixes them evenly with the provided air. This is all done to create an optimal flame, resulting in high-quality inert gas. The startup sequence begins with the initiation of the scrubber. Next, before the oil flows towards the main burner, the pilot burner is ignited. Only after successful ignition of the pilot burner is the main burner started. Due to the ultimizing burner technology and the continuously controlled ratio between air and fuel, the flame is stable, clean, and blue. The almost perfect combustion ensures that there is no soot or residues and hardly any carbon monoxide in the inert gas. To be able to use the inert gas, it has to be cooled. This is first done directly after the flame by a set of sprayers. The sprayers cool down the inert gas significantly, after which it's led into the scrubber. In the scrubber, the inert gas is further cooled to seawater temperature by a set of sprinklers. The demisters ensure that the cooled inert gas does not contain any water droplets. Normally, the water flowing out of the scrubber would draw the inert gas with it into the drain. This would mean a loss of up to 10% of the inert gas. To avoid this, extra large water discharge piping is used to allow for degassing of the cooling water. A special regulating valve is placed downstream to ensure that the water level remains correct. Oxygen analyzers monitor the quality of the inert gas and adjust the amount of fuel whenever necessary. The system also measures how much inert gas is needed and configures the capacity of the inert gas generator accordingly. The internal burner cone is present to maintain a hot enough flame at low capacities in order to keep the quality of the inert gas at its best. The inert gas line is the only way that vapors coming from the cargo could theoretically enter the engine room. This must be avoided at all costs. To make sure that it never happens, the deck water seal is placed in between, making it a very important safety layer on the ship. The deck water seal is essentially a container of water in which the incoming inert gas line is submerged. The deck water seal is not dependent on electricity for its function and can thus also serve its purpose during blackouts. The inert gas line should be much smaller than the deck water seal. The deck water seal is always filled with water, which is continuously replenished. During operation of the inert gas generator, the inert gas pushes the water downwards and can pass freely in the direction of the cargo tanks. Whenever the inert gas generator is not in service, overpressure created in the tanks pushes the water into the inert gas pipe and creates a static water column. This water column stops vapors from the cargo tanks from entering the engine room. To avoid extreme over- or underpressure in the cargo tanks, a PV breaker is installed. PV breaker stands for Pressure Vacuum Breaker. Tank over- or underpressure, compared with the surrounding atmosphere, is dangerous, as it can damage the hull of the ship. The PV breaker also avoids a pressure buildup in the cargo tanks that exceeds the parameters of the deckwater seal. Like the deckwater seal, the PV breaker is essentially a container of water in which the connecting inert gas line is submerged. When pressure in the cargo tanks builds up, the water in the PV breaker is pushed downwards until it can flow freely into the atmosphere. In the reverse conditions, when the pressure in the cargo tanks is lower than the outside pressure, the water is pushed into the inert gas supply line until the air can flow freely into the main line. Although it's generally undesirable to have outside air flow into the inert gas main line and cargo tanks, it avoids the dangers of tank rupturing or damage to the hull.